great processional route of Edinburgh's Royal Mile, sweeping down from the castle to the palace of Holyrood House. The Royal Mile owes its existence to ice. Ice that has covered the British Isles thousands of feet deep again and again in the last couple of million years. If we imagine that the Earth is only 100 years old, that's just the last 16 days. Ice sheets like this one in northern Canada have come and gone more than 20 times as recently as that. As the ice ground its way inexorably over the extinct volcano where Edinburgh Castle now stands, it dumped some of the material that it had picked up on its way. It streamlined the landscape to leave the gentle slope that we now call the Royal Mile in the lee of the rock. The shape of much of our landscape is the legacy of the ice and of the huge quantities of water released by the ice when it melted. Even at its greatest extent, though, the ice never covered the whole of the British Isles. For most of the last 2 million years, the south of England has been tundra, a bit like Alaska today, an almost barren waste with only the top few inches of the surface melting in the short summers and the subsoil permanently frozen. The tundra left its mark too. As the climate gradually warmed up at the end of each cold phase, the surface soil became waterlogged and slowly sludged downhill, sliding on the icy layer underneath. The sludging went on for thousands of years and slowly dug out the dry valleys and hollows that are so common on the North and South Downs. This is the Devil's Kneading Trough on the North Downs in Kent. Further west in the Surrey Weald, the Devil's Punch Bowl was hollowed out by the same sludging process, this time helped by springs. Here, the Devil tried to dig a channel right through the South Downs. He wanted to let the sea in and flood the Weald, but an old lady couldn't sleep. She lit a candle. The Devil thought it was the sun rising, so he ran away and never finished the job. It's a nice story, but the truth is that the Devil's Dyke near Brighton is the result of sludging as the temperature rose at the end of a period of tundra. And the melting tundra released enormous quantities of water. Meltwater carved the Cheddar Gorge in Somerset. Frost was the other big factor in the tundra landscape. On Dartmoor, it shattered the granite of Great Mist Tor. Then the sludge carried the fragments down the hill in a series of great lobes. In the Valley of Rocks in North Devon, sandstone blocks litter the hillside. In Wiltshire, the limestone boulders called the Grey Weathers mark the path of a river of sludge. Fragments of quartzite are scattered all over the Stiper Stones in Shropshire. They're the result of frost and sludge too, as the ice and tundra retreated north. These regular patterns on the ground of Thetford Chase on the Suffolk-Norfolk border come from the tundra too. Nobody knows in detail what caused them, but it's to do with the churning that the ground was given as it repeatedly froze and thawed. pingos. That's the name of these craters not far away on Walton Common. They were formed when mounds of ice pushed up under the surface of the tundra landscape. The soil on top thawed and slipped down the sides of the ice in the same way that it sludged on the downs and the stiper stones. When the ice eventually melted, it left behind these little marshy depressions. The last time the climate warmed up and a thaw began was around 17,000 years ago. Of course, the thaw didn't happen overnight. It was several thousand years before the mountain tops were clear of ice. Even today, this patch of snow on Ben Nevis hasn't completely melted for 60 years. As the melt progressed, prodigious quantities of water were released. And these continued the process of erosion, transportation, and reformation. Meltwater ran in crevasses near the southern edge of a decaying ice sheet. The water dropped sand and gravel, forming these little hills on the North Norfolk Plain. Water ran in tunnels under a glacier in Inverness. The materials it carried settled here to form these ridges. Meltwater formed a lake 56 miles long and up to 100 feet deep in the English Midlands. The Watford Gap near the M1 gets its name from the lake's overflow channel. Glenroy in the Western Highlands of Scotland filled with meltwater 3 times. The parallel roads of Glenroy, the lines on the valley side, are the shorelines of those old lakes. The farmland around Pickering in Yorkshire is made of the fertile soil deposited in another huge meltwater lake. The water cut Newtondale through the North York moors as its overflow channel. It flooded out at something like 10 times the peak discharge rate of the Thames. Just to the north, in Eskdale, water flowed under the ice and cut channels like this in the side of the valley. In places, the water was under such pressure that it flowed uphill. With the huge amounts of meltwater flowing into it, the sea rose 300 feet and drowned river valleys like the Foy in Cornwall. It cut off first Ireland and later Britain and made them into islands. The advancing sea combed up sand and gravel and dumped it on the new shore to form Slapton Sands in South Devon. It wasn't just the sea level that rose, though. The land and seabed are a solid crust resting on an elastic mass of semi-molten magma. As they were relieved of the enormous weight of ice up to 6,000 feet thick, they slowly rebounded. This terrace on the island of Islay off the west coast of Scotland is an ancient beach. Now it's 25 feet above the waves. Most of Scotland is still rising. At the other end of the seesaw, the south and southeast of England are slowly sinking. That's partly why we've had to build the Thames Barrier. The last of the ice and tundra were melting by about 10,000 years ago. Now it's the turn of the rain and the rivers to shape the landscape. Let's see what one river does, the Tees. It rises in the northern Pennines, high on Cross Fell. We'll follow it down to the sea. The Tees begins on a patch of millstone grit covered by a thick mantle of peat. The rain runs over the peat and trickles through it. It gathers to form a stream with enough energy to cut miniature gorges called peat hags. It's already carrying a load of minute particles torn from the land surface, and it's picking up organic acids from the peat. The main stream and its tributaries rush downhill onto limestone, over 1,000 feet in the first 7 miles. It's still carrying particles of peat, but by now it's picking up other materials as well. Its acids dissolve the limestone. Then it meets its first major obstacle, an outcrop of hard, resistant dolerite, providing the basin for Cowgreen Reservoir. The reservoir overflows to the south, and the river continues its journey over the dolerite. Suddenly, the outcrop ends, and the limestone begins again. The river has carved itself a 65-foot drop, high-force waterfall. The brown color of the water shows the quantities of peat and organic acids the river is still carrying. Now the river wanders gently down the limestone valley of Teesdale. It's deceptive, though. A summer rainstorm can quickly turn it into a raging torrent. Past Middleton in Teesdale and back onto the Millstone Grit, the valley widens out. Another limestone valley as it approaches Darlington. Then onto the plain made up of debris left here by the melting ice sheets. By now, the river is less than 200 feet above sea level, with more than 40 miles still to go. Its load of sediment is more than it can carry. The Tees used to flood this plain regularly, dumping layer after layer of sediment from upstream. A marvelous natural mechanism for producing and constantly renewing fertile grazing land. Today, we control the floodwaters and use the land for growing crops. And so the Tees reaches Stockton, Middlesbrough, and the industrial complexes of Billingham. All this rests on material which the river has brought here and laid down over thousands of years. Now the Tees meets its final challenge. It wants to dump its remaining luggage in the sea. The sea has luggage too, which it wants to push up the river. The opposing forces reach equilibrium, forming mudflats and sandbars in the estuary. Britain and Ireland have thousands of rivers and streams, all of them doing what the Tees does, breaking down the fabric of the land, transporting it, and reconstructing it in different forms somewhere else. Rivers take an infinite variety of different forms. They vary according to the nature of the landscape materials they flow over, the climate, which in turn controls sea level and vegetation, and our own activities. In their various ways, they all work on shaping the landscape. The Cuckmere in Sussex cut this gap in the South Downs with the help of the massive thaws as the climate periodically changed. Then it laid down sediment, 90 feet of it in the last 10,000 years. Now it takes a circuitous route to the sea. When rivers start to flow again as a big freeze loosens its grip, they find that sea and land levels have changed. The shape of the land they flow over has been transformed as well by the ice. So they do some apparently very odd things. The Blackwater in County Cork takes a sudden right-angled turn to the south instead of carrying on across the plain. There must have been a quite different landscape here, dictating the Blackwater's course, until the ice changed it all. The Findhorn in northeast Scotland has cut its way down in a series of terraces as the land has risen. The meanders of the River Wye in Gloucestershire first took shape on the surface of a floodplain. Since then, the land's been lifted up, the sea level has risen and fallen, the river's loads of water and sediment have changed time and again. The old floodplain has long since been eroded away, and the meanders have cut down into the sandstone and limestone below. So the Wye at Simmons Yatt still flows in great meandering loops, even though it's now in a deep gorge. The Bristol Avon is the most perverse river of all. It flows 90 miles in an almost complete circle to cover 15 miles as the crow flies, and on the way it carves the Clifton Gorge on the edge of Bristol. The reason it takes such a circuitous course, and that it cuts through the limestone rather than go round it, is quite simply that it's older than the landscape it now flows over. As the rivers take over the job of shaping the landscape from the ice and the tundra, they change themselves, of course. Here, in the Vale of Llangollen, the River Dee had such a large extra load of meltwater to carry that it changed its course. This old meander was cut off. The effects of ice, tundra and meltwater can be seen all over Britain and Ireland. Even 17,000 years after the last ice sheets and glaciers began to melt, ice, albeit on a smaller scale, still works on our landscape. Mount Egluiseg here is constantly being broken down as water freezes in the mountain's limestone fabric and the ice levers fragments off to form these screes, tumbling down into the Vale of Llangollen. Imagine huge ice sheets, thousands of feet thick, beginning to melt 17,000 years ago. The River Dee, in the Vale of Llangollen, becomes so swollen with meltwater that it straightens its course, cutting off this old meander. Over 75% of the Earth's surface is water, either frozen or liquid. As well as that, there's water vapor in the Earth's atmosphere. At any one time, water vapor accounts for less than 1/1000% of the Earth's total ration of water. But even that tiny percentage is still a fair amount. It's around 3,000 million gallons. To put that in some kind of perspective, it would take the Thames at Teddington Lock at its record flood level something around 800 years to shift all the water in the Earth's atmosphere. There's a constant cycle. The water evaporates to form cloud, then the vapor condenses and it falls as rain or snow. The water moves down into the oceans, only to be evaporated again. That cycle's a potent force in the breakdown, movement and reconstruction that go on all the time in the fabric of our landscapes. Since the last ice retreated and this part of the Earth's surface has had a temperate climate, the rain and the rivers it generates have been the main agency in the never-ending attempt of the elements to level the land and sweep it into the sea. Water may seem fairly harmless, but in quantity and over time, it makes enormous changes. Half a dozen little streams, none of them rising more than 5 miles from the sea, have enough power to transport all this mud into Chichester Harbour. The river that flows off the Wicklow Mountains into Glendalough runs only 4 miles. But the sediment it carries is enough to have advanced the shore of the loch by several yards in living memory. "700 years ago, Harlech Castle stood beside the sea. It was built with a water gate. But since then, 2 rivers running off Snowdonia have enlarged the marsh with their sediment. The sea has used the enlarged marsh as a foundation for building sand spits and dunes. The water gate is now 3/4 of a mile from the sea. When water falls on the land, it does one of 3 things. If the land surface isn't absorbent, for example, if it's dense rock with little in the way of pores and cracks, it runs straight off. More often, though, it filters into the soil. Some of it stays there in storage until the temperature rises enough to evaporate it again, or plants draw it up through their roots and transpire it from their leaves. Some of it moves downslope in the soil or percolates through to the groundwater and eventually emerges in springs or seeps out to form rivers. The proportion of the rainwater that follows each of these routes varies with the type of surface it falls on. Vegetation cover makes a huge difference too. It helps the land to absorb the water rather than throw it off. Woodland like this will store the water for a time before it reaches the ground and help the soil to absorb much more. Broadleaf trees store water better than conifers. Any trees are better than grassland, and bare, unprotected soil is soon eroded and carried off by the falling rain. The peat here on Cross Fell, near the source of the Tees, is normally very absorbent, but a hot summer will bake the surface dry and hard. If there's a summer storm, the rain runs straight off into the river and causes flash floods lower down. If a hard and dry surface can throw the rain straight off, so can a waterlogged one. 1952 was a wet summer. North Devon had its average August rainfall in the first fortnight of the month. Exmoor was saturated, so that when a great storm threw down 9 inches of rain in the night of the 15th, it could absorb no more. The picturesque little East and West Lynn rivers were asked to cope with as much water as the Thames in flood, and the Thames drains an area 100 times larger. Their steep gradients speeded the flow of the water, and in Linton and Lynmouth that night, 34 people were killed. In 24 hours, the West Lynne moved 50,000 tons of boulders weighing anything up to 10 tons each. The debris created a new delta on the right bank of the East Lynne. Near the source of the West Lynne, high on Exmoor, the scars of landslides are still there 35 years later. Some of the most spectacular changes in our landscape are caused by rain. Dennis Brunsden is Professor of Geography at King's College London. But water doesn't need to take the form of a river to change the landscape, does it?
No, it doesn't. When rainfall falls on the ground and soaks into the ground, it has a very different effect. Perhaps the most important effect is to create landslides. Here on the Dorset coast, for example, we have perhaps the best landslides in the country. Classic site. I love the area. And here we are on Stonebarrow, which is a very famous landslide in many ways, and it illustrates the point very well. I think if we look up the cliff, you can see the loose nature of these materials. On the top, there is a material called chert, rather blocky and loose. That lets water in, soaks into the ground. Then there are sands, and these also let water soak down through, until at depth, suddenly it meets clay, the lias clays of Dorset.
And these are...
Oh, this is about 100 feet down. And the water can't escape, so it builds up considerable pressure in the hill at that point, and starts to make the hill unstable. And at the same time, the sea, of course, is cutting back into this cliff and making the cliff very steep.
A double action.
Double action that just makes the hill very unstable so that it collapses. And at this place, it collapses in a particular form. There's a curved surface under the ground here on which this material is moving, and so that the pieces, when they come down, rotate as they move towards the sea. It's called a rotational landslide.
This hut over here seems to be tipping backwards.
Yes, it is. This is a perfect example of it, really, because this was sitting on the top of the cliff, and as it came down the hill, it turned backwards like that. This is an old radar hut from the first radar stations built in this country in the Second World War. It was on the top of the cliff there in 1942. The story is that the men had just come on shift, 8 o'clock in the morning, and they walked out, got into the hut, and it descended the hill, about halfway. I don't think anyone was hurt, and then since then it's subsided down to this position.
They must have been quite surprised.
A bit surprised, yes, but I think the interesting point is that it illustrates that this whole block of land here came down on this curved surface, rotating, so that in 42, if you'd walked out to the edge of the cliff and looked out to sea, this would have been the place.
Good for it.
Yes. But this is just one type of landslide, the rotational landslide. There are many other sorts. Just over here at Black Fen, we have a different sort called a mudslide, perhaps the biggest, most spectacular, active landslide in Europe.
This is all mud.
This is all mud. This is a mudslide. Now, when we were at Stonebarrow, we were talking about a rotational movement.
Yeah.
Here, it's quite different. Again, we've got the same sort of rocks with the permeable chert and sands, which are soaking up water. And that water gets to the bottom where the clay is, and I think you can see the change in colour. The blue colour comes in. That's the blue lias clay of Dorset with the sands above it. And there's a dark line just at the very top. That is the surface which is trapping the water and also over which the sand is moving. Under the effect of high water pressure, those sands descend the first cliff and land on what you can see as a series of terraces there. There's mud already on those terraces from previous episodes. That mud lands on top of what is there, loads it, increases the water pressures inside the hill, and sends the thing forward, and it goes over the next terrace edge onto the terrace below and does the same again and again until finally it comes to here and pushes this great lobe of mud out into the sea. That first happened, as far as we know here, in the winter of 1957 to 8, when two lobes came down. There's one that we're standing on here, and then another one just here with vegetation on, a little beach in between. And a man was actually trapped on that beach and had to be rescued by a rowing boat. And it happens many times. 1957-8 was one season. 1969 was a very bad season, again, when this all surged forward. And then it went very quiet until the 80s. And in certainly the last 2 or 3 years, this has been quite active again. And this last year, which has been very wet, the mud's been pouring everywhere. Everything you see here, without vegetation on it, was moving this winter. And I think you can see now that it's drained out, it's solid, and, you know, you can stamp on it. But if we were here in winter, you'd just go straight through, you know. And it's very, very dangerous here at that time of the year. And this is why there are signs on the beach saying, you know, mudslides, be careful.
People certainly shouldn't walk around.
Oh, yes, you get stuck in this very easy. But that happens every year, of course. It's just that certain years are wetter than others. And these are seasonal features. And in fact, that lobe in the sea there, in February this year, a third black ven took place. And of course, there are thousands of other landslides in Britain. There's been a recent survey carried out which has shown that there are nearly 11,000 known landslides, recorded landslides in Britain in one place or another. And they range in type from mudslides to rotational slides. Some are fast, some are slow, some are very, very small, just a little bank collapse on a river, and some are as big as this, one of the biggest in Europe. So there are many of them. And this coast, all the way into East Devon, is very famous. Just beyond where we are now, beyond Lyme Regis, we have the Landslide Nature Reserve, so called because of the famous Bindon landslide of Christmas Eve 1839.
Oh, what's that?
Oh, it was a wonderful event when a very large block of material, now called Goat Island, bodily moved outwards, leaving a great chasm behind it, which is some 200 feet wide, 200 feet deep, about a mile long. And this whole block moved out with cornfields on the top and
Good
so on.
Lord.
And it was so famous. It was partly famous because a man was on it. A Coast Guard was in his house when
and
it
he was
happened.
moved with it?
He was moved with it, and the house was distorted, and he had to be rescued. And they got him out through the window. The door couldn't be opened, and they said to him, you know, what happened? And he said something like, "Ah, there came a wondrous crack." And that's basically all we knew at the time. It became famous also because there was a lot of iron pyrites in the clay, and when the landslide moved, this went off under a process known as spontaneous combustion, and there were sparks and the smell of sulfur, so everyone said the area had been visited by the devil, you know, all this sort of thing. But there were two geologists there, Conybeare and Buckland, and Buckland's wife, Mary Buckland, who've made the most wonderful drawings of it, so we've got a very fine record of this. And it became very famous, partly, I think, because of all the prints that were made from those drawings, but also because they eventually harvested the corn using ladders to climb up the thing. Oh. And then a man called Ricardo Linter, who made a living writing pieces of music about famous Victorian events, wrote a piece of music called the Landslip Quadrille about it, and then they used to bring people from Weymouth on paddle steamers to view this extraordinary explosion of nature. And then as they went back to Lyme Regis having tea, they danced to the Landslip Quadrille on the paddle steamers as they went back. So that's a lovely landslide. But of course it's one of the big ones, one of the spectacular ones. It didn't do any damage, but it's just a nice one to see.
Dennis Brunsden said that the rain, by causing landslides, gives us some of our most spectacular landscape features. On the Isle of Skye, the Store is one of our biggest landslides. It certainly makes his point. Huge blocks of basalt have been carried down towards the sea as the clay below has failed. The Needle Rock stands defiantly at the top. But for how long? Garran Point in County Antrim, at the northeastern tip of Ireland, is another big rotational landslide. Chalk and basalt produce this stark contrast of blacks and whites. In the English Peak District, the Arctic ice steepened the sides of the Allport Valley. As the rain saturates the clays below the slope surfaces, great blocks of millstone grit collapse down the sides. The natural pinnacle left standing on the valley side is Allport Castles. Rainwater by itself, or with the help of gravity, can move the landscape around quite radically. It changes it in other ways too. Rain is a dilute acid because it picks up natural carbon dioxide from the atmosphere, not to mention the acids that we pump into the air from our coal-fired power stations and our car exhausts. This gives it the power to dissolve limestone. This block of millstone grit was dumped on the North Yorkshire limestone pavements by melting ice 15,000 years ago. It's acted as an umbrella, protecting the limestone beneath from solution by the rain. As it sat here, the rain has slowly dissolved the pavement around it and lowered it by over a foot, leaving the block sitting on a limestone mushroom stalk. Just over a mile away, rainwater gives a graphic demonstration of its power to dissolve the limestone. Fell Beck flows off the neighbouring millstone grit. Over time, it has worn and dissolved its way through the limestone surface. Now it plunges 365 feet down Gaping Gill, Britain's largest cave. Water dissolves chalk much faster than it does the stronger limestones. It's porous and absorbent, so the water constantly trickles down through it, insidiously eating it away. In this Kent quarry, the rain has dissolved the chalk beneath, and the ground surface has sunk as a result. Porous materials, like peat and some forms of clay, expand and contract enormously with the amount of water they have to hold, and the water itself expands when it freezes. This all churns up the surface and leaves its mark. Expansion and contraction and downhill creep under the force of gravity, that's what causes these little terraces on a slope on the North Downs. What we do often accelerates the creep downhill. We disturb the topsoil by ploughing, and before long the white chalk is showing through at the top of the slope. We remove trees from a hillside on the downs, and we loosen the soil anchored by their roots. It creeps gently downhill, and soon there won't be enough left to plant new trees in. Change in the landscape can sometimes take us by surprise. Coastal landslides on the Isle of Wight cut the road here, and it had to be rerouted. Some parts of the coast change very fast. Here on the North Devon coast, the cliffs have been worn back so far that streams have been left hanging in mid-air. The force of gravity, the rain and the rivers, the snow, the frost, the ice, and the waves hammering at the shore all conspire to level the land and to turn the Earth into a uniformly smooth, featureless globe.